Electron transport chain, ETC, stage 4 of carbohydrate metabolism. What are the 4 stages of carbohydrate metabolism? There are 4 stages of carbon metabolism. Stage 1 is glycolysis, including glycogenolysis, right? And stage 2 is the conversion of pyruvate to acetyl coenzyme A. And stage 3 is the TCA cycle. And stage 4 is today's lecture, is electron transport chain. This lecture is about stage 4 of carbohydrate metabolism occurs in mitochondria. Dr. Peter Dennis Mitchell was a British biochemist who was awarded the 1978 Nobel Prize for Chemistry for his discovery of the chemiosmotic mechanism of ATP synthesis. He introduced his hypothesis in 1961, and the Nobel Prize for Chemistry in 1978 awarded to him recognized his predominant contribution toward establishing the validity of chemiosmotic hypothesis. This is outer membrane of mitochondrion. This is an inner membrane of mitochondrion. This is intermembrane space, and this is matrix. The ETC is composed of 5 cytochrome protein complexes. 3 complexes, which are proton pump, are embedded into the inner membrane of the mitochondrion. There are complex 1, and complex 2, and complex 3. This is ATP synthesis. While 2 mobile carriers, mobile carrier Q and mobile carrier C, shuttle electron through the ETC. The ETC is where the greatest amount of ATP is synthesized. NADH plus proton arrives from stage 2 of carbohydrate metabolism or stage 3 TCA cycle to the ETC and immediately oxidize to NAD plus with its proton hydrogen ion going into the matrix and each electron going to cytochrome complex 1. As the electron arrive on cytocomplex 1, the complex immediately go through redox, reduction and oxidation. So this reaction creates a proton pump with the cytochrome, so pumping some proton from the matrix through the cytochrome into the intermembrane space. How about like this? And the electron now transfers to mobile carrier Q, and NAD plus return to its original source. The electrons are transferred to cytochrome complex 2 and it immediately go through redox, reduction and oxidation. This creates a proton pump, pumping proton from the matrix through cytochrome complex 2 directly into the intermembrane space of the mitochondria. The electrons are now shuttled to cytochrome complex 3 by mobile carrier C. As the electron transfer to the cytochrome complex 3, it immediately go through redox. This creates a proton pump, pumping proton from the matrix through cytochrome complex 3 directly into the intermembrane space of mitochondrion. Now, electrons have no place to go from cytochrome complex 3, So, an oxygen atom. Did you remember which one is an electron hole? Oxygen, right? Which has a very strong attraction for electron, pick up a couple electron from cytochrome complex 3 and 2 proton from the matrix to form water. In essence, the final acceptor of the electron at cytochrome complex 3 is oxygen, which form water with the proton and electron. This is actually 20% of the water our body uses. The rest we must intake in our fluid and food. And it is referred to as a metabolic water. The many protons in the intermembrane space have created a hydrogen ion concentration that the cell does not like. All cells prefer homeostasis with their organelles. Therefore, ATP synthase, a protein embedded in the inner membrane, pump the proton back into the matrix. As the proton go into the matrix, energy is liberated to phosphorylate ADP with an inorganic phosphate. Thus, synthesize ATP. The ATP will leave the mitochondrion and go where it is needed for energy in the cell. The difference between NADH plus proton and FADH2. FADH2 arrives from the T-cell cycle to the ETC and goes directly to the cytochrome mobile carrier Q rather than cytochrome complex 1. FADH2 oxidized to FAD with its proton going into the matrix and its electron going to mobile carrier Q. Mobile carrier Q shuttle the electron from FADH2 to cytochrome complex 2. The electrons are transferred to cytochrome complex 2 and it immediately goes through redox. This creates a proton pump, pumping proton from the matrix through cytochrome complex 2 directly into the intermembrane space to the mitochondrion. And FAD returns to the T-cell cycle.